This is problem number 26 of the 2012 AP Calculus exam. Let g be a function with the first derivative given by g prime of x is equal to the integral from 0 to x of e to the negative t squared dt. Which of the following must be true on the interval from 0 to 2, where x is greater than 0 and less than 2? Well, let's start with what's given. G prime of x is equal to the integral from 0 to x e to the negative t squared dt. And I really don't know what that graph of e to the negative t squared looks like, but what I do know is it's positive, because even if I take that term to the denominator and change that exponent sign to a positive, I'm still going to have a positive value. So it doesn't really matter what the graph looks like, we just know it's positive. So I'm going to be thinking about it this way. I've got some strange graph from 0 to 2, and I've got some area under the curve. We're taking the integral, and we're thinking of this as being like this interval from 0 to 2. And what I notice is I have this area that's above the axis and therefore positive. So g prime of x is positive, it's greater than 0, which means if the first derivative of x, of g of x is greater than 0, it's increasing, or g of x, would therefore be increasing. Let me say that again. We see that this is a positive area, and therefore g prime of x is greater than 0. And if g prime of x is greater than 0, then g of x is increasing. And so we can, in this case, eliminate some answer choices like C and D and E, and determine now, is this function of g of x, is it concave up or down? And since I'm given the first derivative, and to determine concavity, we look at the second derivative, I only have to take the derivative one more time. So let's go on. G prime of x was equal to the integral from 0 to x of e to the negative t squared dt. So if I take the derivative of that term, the second derivative now in this case, because it's g double prime of x, then I'll be taking the derivative of that right side with respect to x. And if I take the derivative of the integral, I'll get the function itself. So I'll have g double prime of x, or the second derivative of g, will equal e to the negative x squared. And that's what I've got. So now let's think about, what does that is that function positive? Is it negative? Is it 0? Well, it can never be 0, and it cannot be negative. Even if I take that exponent and bring that term to the denominator, it just makes it 1 over e to the x squared, still a positive value. So g double prime of x is greater than 0, and therefore g of x is concave up. If it's greater than 0 or positive, it's concave up. If the second derivative is less than 0, it's negative, and therefore concave down. So this problem, it's concave up. Answer choice, letter A.